Hello, this is a short video presentation on adding and subtracting and multiplying imaginary and complex numbers. Adding and subtracting is very straightforward and simple. Remember, our numbers are in the form a plus bi, where this is the real part and this is the imaginary part. All we do is add the real parts and the imaginary parts. So, if we had 4i plus 3i, only real or imaginary parts, it'd be 7i. Sort of like the I was a variable. It isn't. It represents a number, the imaginary unit, but you can think of it in terms of being like a variable. If we had 2 plus 3i minus 4 minus 2i, whenever we're adding and subtracting and we have complex numbers, imaginary and real parts, we use parentheses 100% of the time. Now, just look at the real part. 2 minus 4 is negative 2. 3i minus negative 2i would be like 3i plus 2i. We distribute that negative, and we get plus 5i. Adding and subtracting is extremely straightforward. It operates just like you would have suspected. Multiplying is different. Multiplying has a huge thing we have to resolve, I guess, is the easiest way to put it. When we multiply the square root of 2 times the square root of 3, we multiply the radicands, and we get the square root of 6. When we multiply the square root of negative 2 times the square root of negative 3, this does not apply anymore. This is not equal to the square root of 6. We cannot multiply those together because it essentially cancels out the fact that they're imaginary numbers. So, before you multiply, before multiplication, we must simplify. This is without exception. You must do this. So this equals I square root of 2 from yesterday times I square root of 3, which is I squared square root of 6. I squared, remember, is negative 1, so we have negative square root of 6. Had we multiplied the negative 2 times the negative 3, we would have gotten the square root of 6, but we would have not gotten this negative. Let's look at one more. Square root of negative 2, square root of negative 3, square root of negative 12. Now we have I square root of 2 times I square root of 3 times square root of 12, remember, 4 times 3. So we have 2i square root of 3. Now we multiply, and we have I cubed times 2. Square root of 3 times the square root of 3 is square root of 9, or 3. And we have square root of 2. Now, I cubed from yesterday is negative I, so we have negative I times 6 square root of 2, and putting it in the proper form, negative 6 I square root of 2. Like we said yesterday, the radical must come after the I, and the number always comes before I. Now, this was pretty straightforward. We were only multiplying radicals. What happens if we multiply complex numbers? 2 plus 3i times 4 minus 2i. Now, all we're going to do is FOIL. So, 2 times 4, 8, minus 2 times 2, 4i, plus 3 times 4, 12i, and then minus 3 times 2, 6i squared. I squared, remember, is negative 1. So we have 8 minus plus negative 4 plus 12 is 8i, minus negative 1 times 6, minus a negative plus a positive, 8 plus 6, we have 14 plus 8i. All right, let's do one more and then we'll be done. Four minus 3i squared. So we have 4 minus 3i times 4 minus 3i. And still, a lot of us forget to write this out. When it's a binomial squared or a complex number squared, write it out, and we end up with 16, 4 times 4, 4 times 3 minus 12i, minus 12i, plus negative times negative, positive 9i squared. And then we have, actually we can do this all in one fell swoop here, 9i squared. The I squared is negative 1, so this becomes a negative 9. And we end up with 16 minus 9, 7 minus 24i. The big thing to remember is when you're multiplying imaginary numbers, and even though you don't see the I, it's an imaginary number. When you're multiplying imaginary numbers, when they're in the radical form, you must simplify before you multiply. All right. Hope this is pretty understandable for you, and have a great day.